Aldosterone, the point is to, because our final product is going to be aldosterone, right?
Mm-hmm.
And so what does aldosterone do?
I looked over it
Okay, so what aldosterone does is we're going to increase sodium reabsorption. All right, so we're going to hold on to more sodium. Okay, and kind of a general rule is that wherever sodium is, water is going to follow it. Right, and so because we're retaining sodium, we're also retaining water, which causes blood pressure to go up. Right, because if you increase blood volume, you increase blood pressure. Right. Because basically at the kidneys we've got like the glomerulus thing, kind of goes in like that, and it comes out this way, right? So we're going in this way, coming out this way.
Mm-hmm.
And so the blood pressure in here needs to remain constant, right? Because if it's too low, because there's pressures working against it, right? And so if these are greater than this, you're not going to get any filtration, right? So we need to build up this pressure so that we can have, filtration. But this also can't be too high or else you'll damage the glomerulus and stuff, right? And so when you increase the pressure going in this way, you increase the filtration pressure, right? So like right here, there's the juxtaglomerular apparatus, right? And what that does is it measures flow, right, into the kidneys. And so if the flow is dropping, it's going to, or the pressure is dropping, it'll secrete renin to start this process to bring the pressure back up. Or the, the macula densa? Yeah, the macula densa cells, they are measuring the amount of sodium, okay? And so same thing, if sodium level drops, then they secrete renin, right? Okay, so the first thing we have is renin. Okay, so renin, so this is coming from the kidneys, right?
Mm-hmm.
Then our liver, meanwhile, is producing something called angiotensinogen.
Mm-hmm.
When you see this ogen at the end, usually means like an inactive form of something. Like in the stomach, for example, pepsinogen is the inactive form of pepsin, right? So, yeah. All right, and when renin and angiotensinogen combine, they produce angiotensin-1. Okay. Cool. All right, so then in the lungs, there's this enzyme called ACE, or angiotensin converting enzyme, right? Which is in the lungs. And then that causes angiotensin to turn into angiotensin 2. Okay? And what angiotensin 2 does, meanwhile, it goes through the body and causes vasoconstriction. Right, so it's going to cause all the blood vessels to constrict to increase blood pressure, right? All right, and then the angiotensin 2 goes to the kidneys, to the cortex, and produces aldosterone. So it goes to the kidneys. Well, technically, it goes to the adrenal glands. which are not the kidneys, but they're on top of them, right? Adrenal cortex, which are endocrine glands that secrete this, which is a hormone. Make sense?
Mm-hmm.
So, and then aldosterone causes this to happen, right? So this acts upon the kidneys, right? Aldosterone will then go to the kidneys, and in the like distal convoluted tubules and things like that, it's going to cause more reabsorption of sodium, and then which will cause more water reabsorption and then higher blood pressure, right? So, so yeah, it's kind of like, why is there such this like complicated pathway? And one of the things about renin that's cool is that because it has multiple stages, it's kind of slower to get going, but it's longer lasting. Does that make sense? Because, for example, to adjust this blood pressure, you also have like these muscles right here.
Right.
The precapillary sphincters, right? So like if you wanted to decrease blood pressure, this would constrict and this one would dilate. If you wanted to increase blood pressure, you'd dilate this one and constrict this one, right? But that's kind of like an immediate temporary response, because the easier thing would be to adjust the overall pressure coming in so these ones don't have to constantly being like contracting and stuff. And so it causes kind of like, all right, let's just change all of the blood pressure to make it work right here. So, let's see.
And so with renin, if something goes wrong with that apparatus and it didn't secrete renin,
Right.
and none of this happened, even if you had normal blood pressure and then just quit, then would it just drop your blood pressure like eventually?
Yeah, well,
Eventually, because nothing would be.
yeah, well, there's other things that increase blood pressure, like ADH, right?
Right.
But so let's talk about this a little bit, because this is kind of what will help you out. So, first of all, what type of drug do you think you could give a person to stop this cycle in any of these points to lower blood pressure? Let's say somebody has really high blood pressure and they're still secreting a lot of renin for some reason. Like, what could you give? Yeah, right. And that's this is where it's hard, because you've probably never heard of some of these drugs, but they would make sense if I were to tell them to you, right? Like one blood pressure medication is an ACE inhibitor. So how would that decrease blood pressure?
You wouldn't get to. I guess that beginning cycle would work, but then not the enzyme in the lungs wouldn't work.
You pretty much stop it right here, right?
Right.
So all the parts of renin that actually cause a rise in blood pressure don't happen, right? So that would be a good thing, right? If you had chronically high blood pressure, ACE inhibitor would be good, right?
Mm-hmm.
Let's see. That's kind of the main one with that one. I believe there also can be like just a renin inhibitor as well. Or you could get like a drug that would be a vasodilator, right, to counteract this.
Right.
And also stop stimulating renin, right? Because, well, actually, that would cause more, right? Because this, if there's dilation right here, it'll be like, hey, we need to just constrict, so let's do renin. So.